Good morning, good afternoon, or good evening, depending on where you're joining us from. I'd like to thank everyone for joining this presentation from Parker Lord on lightweighting for internal combustion engines and xEVs. My name is Stephen Webb. I'm one of the senior application engineers here at Parker Lord, and I'll be giving the presentation today. I'd like to briefly go over the agenda before we get into the meat of the presentation. Initially, I'll talk about a little bit on who is Parker Lord, as well as then I'll be moving into lightweighting, some of the macroeconomic trends and legislation that's going on. A little bit of introduction if you're not already familiar with that internal combustion xEV model. After that, we'll be touching base on Parker Lord solutions, really for adhesives and lightweighting, and then solutions themselves for the xEV. This is more thermal and battery solutions. At the end, we'll have time for a question and answer, so I look forward to all the questions. Certainly, throughout the presentation, you can present information within the chat section if you have questions. So first, an introduction. Who is Parker Hannifin? Parker Hannifin is a large multinational corporation. We focus on these primary areas you see here: aerospace, automotive and electric vehicle, defense, general industrial, life sciences, mobile industrial, oil and gas, and telecommunications. We have about $19 billion in annual sales, over 900,000 products, 550,000 customers, 17,000 distribution and MRO facilities, 65,000 employees globally, 335 manufacturing in over 43 countries. So as you can see, we're a fairly large multinational corporation. Drilling down a little bit, I'd like to highlight some of the things on the Parker Lord division. So Lord Corporation was purchased by Parker Hannifin about 3.5, 4 years ago, and we've been since integrated into the Parker Hannifin Corporation. We're part of the Assembly and Protection Solutions Group, and here you can see some of our international locations that really deal with just the solutions we'll be presenting today, where we manufacture them, some of our technical centers, etc. So as you can see, within North America, we have production facilities in Sagertown, Pennsylvania, and Indianapolis, Indiana. We have production down in Hyundai, Brazil, Hilden, Germany, Nagoya, Japan, and of course, Shanghai, China. Furthermore, we have technical centers all across those continents as well, and to support those things as well as R&D. So a little bit about Parker Lord and a partnership. We really do truly believe that our customers are partners and we like to treat them as such. So to give you an example, we touch base on all the different global manufacturing locations. Well, that gives Parker Lord the ability to collaborate with you, our customers, as other multinational where you might be designing in the United States or in Europe and getting manufacturing in Asia or down in South America. We have those global manufacturing facilities and the internal collaboration within teams to support that. Application engineering support, that's actually what I do. So my job is really from the design end of a new product, helping out with suggestions on utilizing adhesives or lightweighting solutions, all the way through DPAP towards the end of manufacturing and even during manufacturing implementation. We even come out and offer training to customers. Customization and scale up. This is an area where if an individual product isn't quite meeting the needs of the customer, you, our partner, we can certainly look at customizing those products and or scaling them up to necessary levels to support your production. Of course, this is always a business decision, but I do want to offer that that's something we quite often do. Safety and sustainability. That's a key attribute that Parker Lord and Parker Hannifin as a whole focuses on. So whenever we're dealing with our customers, our partners, we look at safety and sustainability as being key and integral to part of those decisions and whether those products are selected. And again, partnerships. This kind of all brings it together. We really do value our customers as partners, and we look at long-term relationships with them. So now I'd like to talk a little bit about lightweighting trends that we're seeing both from the governmental side and regulations and so forth to the consumer side. So as I mentioned, lightweighting trends, these are really looking at reaching emission targets. So what we're trying to do is, of course, make the vehicles lighter so that we can hit these increasingly more difficult CO2 emissions targets. And you can see the chart on the right, we're looking at grams per kilometer driven in the years 2016 through 2025 for various countries, United States, the European Union, China, Japan, etc. And there's the projected and actual targets there. So again, those global regulations have called for higher and higher emission standards over time, And this, of course, necessitates the usage of lightweight materials in the vehicle. But if you notice, I use the term have called because, of course, as we've all experienced, the regulatory environment is changing. What we're seeing now is lightweighting measures, just as a quick note, on those 2030 and 2035 standards. If we lightweight everything with an internal combustion engine and optimize and so forth, it's expected we won't be able to sufficiently reach those CO2 targets using an ICE standard, which is kind of why everyone's looking at lightweighting and moving over to other hybrid drive systems and battery electric vehicles, etc. That being said, as we mentioned, the regulatory environment. So previously, California and the California Air Resources Board has had the authority to preempt the federal standard, making their standards higher than the federal standards in terms of emissions. A number of other states joined California in doing that. That authority has been preempted. That preempting authority, has been rescinded. And so California, not necessarily the other states, can no longer put forth these higher standards. As well, they're looking at removing the finding of it's a legal finding for the 2009 for greenhouse gases. This is kind of the basis by which greenhouse gases began to be regulated. So not just for the automotive industry, but elsewhere. That's going on at the EPA in the United States. The European Union really has looked at rolling back some changes and targeted tariffs on incoming systems, particularly from China. Probably the biggest change is right now that there's an e-fuel carve out for the German brands starting in 2035. So in other words, they can still continue to produce internal combustion engines provided they run on e-fuels. I think it's probably a recognition of the changes and so forth and the difficulty really. So again, I mentioned lightweighting can help so we can get to these, reduce those CO2 emissions. Generally, it's been accepted that you can get about 0.08 grams of CO2 reduction per kilogram saved in an average vehicle. So that's what we're seeing on the regulatory side again. Quite a few changes, probably more changes to come. And then we can certainly expect if the administrations change in the future and here in the United States, that your pendulum will swing back the other way. So now I'd like to talk about some trends in demand. So going from the regulation and governmental side to the business side and consumer demand side. So what we've seen here is a flattening of demand globally on average in the European Union, which has some of the highest adoption rates, and also here in the United States, which is kind of lagging behind the European Union. So the OEMs have witnessed this flattening of demand. There's certainly been changes in terms of the incentive packages. And so those BEVs, the pure battery electric vehicles, we're seeing a shift more towards the plug-in hybrid, and the hybrid electric vehicles are certainly increasing in the European Union. As I mentioned before, those reductions in incentives have really kind of made some changes in who's buying what more than anything else. So there was a dip initially in sales in 2024, beginning of 2025, as those incentives in the European Union fell off. We just saw them fall off in the United States. However, that rebounded a bit and did a little bit of digging into that. And really what it's done is moved to less expensive brands, and that being the Chinese brands, kind of at the expense of the European local brands, particularly with the plug-in hybrid electric market. Interestingly, the statistic that I was finding was that between January and August of 2025, there's been a 14-fold increase in those plug-in hybrid electrics from the Chinese companies. We also see that the OEMs, based on this, have begun to reevaluate their product offerings. They're moving away from solely battery electric, or their plans to have solely battery electric as soon as they've mentioned in the past. So moving the dates out to moving towards plug-in hybrid electric, hydrogen fuel cells, etc. And most of the major brands, Ford, GM, Volvo, Volkswagen, Toyota, Honda, have all announced plans, with the Japanese and the Korean brands really focusing on plug-in hybrid electric vehicles. So what we're seeing here in the demand basically is a disconnect between the consumer demand and the consumer ability to pay for these non-ICE vehicles, the battery electric vehicles, the plug-in hybrid electrics, etc. Still maintaining the lower cost. Those regulations have been driving it. The regulations have changed. The automotive brands are now responding to that and leaving CO2 reduction kind of up in the air right now going forward. So I mentioned several different platforms. I just wanted to clarify my terms that I've been using throughout here with this next slide. So the first one here is this xEV. Term may or may not survive, but xEV is really referring to a new term referring to one platform using to encompass multiple drive lines, which can be installed on it. So an ICE vehicle, a battery electric vehicle using a common platform, or a range of vehicles offered within that platform with different driveline systems. The first one up is the one we all know. This is the battery electric vehicle. So this is solely a large high voltage battery, electric motor driveline, no internal combustion at all. A plug-in hybrid electric. So this one has typically a larger high voltage battery. It does still have an internal combustion engine and also an electric motor system for drive, depending on the manufacturer and the configuration. I mentioned larger because with a hybrid electric vehicle, they typically have smaller high voltage batteries. Again, still an internal combustion engine with an electrical assist, that kind of being the difference there. So they don't plug in at all, they just use gasoline, but then use an electrical assist along the way. And lastly, there's this fuel cell EV. So this is using some of the same platform architecture, high voltage battery, electric motor for drive, and then a fuel cell for providing the electricity either to motive drive force or to the battery or both. And then lastly, the internal combustion engine. So it still continues. Consumer demand, or at least their ability to pay at a certain price point, continues to drive ICE. But again, lightweighting still has to occur. And so that's really kind of driving all of this, as we still need to get lighter and lighter materials, satisfying the need for a good vehicle that we're producing. Up until now, we've spoken about really light duty trucks and light vehicle market, but I'd like now to turn and talk about final mile and heavy duty delivery truck market segments. So as manufacturers are exploring the battery electric or the xEV platform, it seems like that matches well with the duty cycle of many final mile delivery vehicles. You can see a couple of examples down below of Federal Express or UPS type delivery trucks. Many of those manufacturers look at those duty cycles where you have an individual operator that drives a given route during the day. The vehicle is brought back to some sort of home station, refilled during the second shift to prepare for the following day's production, and it's recharged during that time. So again, that's kind of that duty cycle, and it seems to fit well with an xEV platform. As the manufacturers have looked at these, there's been a growing demand for new designs, and they've continued to push for an extended range, which will, of course, force lightweighting into these designs. Lastly, I want to speak about heavy-duty truck segment. They are facing increasing regulations for pollution and carbon reduction. However, the driveline changes are right now in flux. There's many manufacturers that are still considering what those options might be, although lightweighting is still a significant need for this market segment. In terms of materials being adopted for lightweighting, I'll briefly touch on this on some of the trends. So the biggest trend, as everyone knows, is the high strength steel, advanced high strength steel, or ultra high strength steel that are being employed in the passenger light vehicle and light truck segments. So these metals offer the ability to basically down gauge or reduce the thickness of the material due to the increased stiffness or rigidity of these materials, or better ductile properties. And so you're overall able to reduce the gauge thickness and or weight by using these higher strength newer materials as the alloys have been developed. Aluminum and magnesium alloys should now also be considered as mainstream within the automotive industry. Aluminum has now moved to the second highest usage metals in all of transportation, with magnesium alloys coming in third, somewhat distant third. Composites and thermoplastics, I'll briefly mention those. Composites still seem to maintain a niche market segment with respect to carbon fiber, although many other materials such as sheet molded composite or the variations thereof and or thermoplastic composites seem to be making quite a bit of inroads both in engine internal compartments and hidden areas such as the reinforcing panels in between closure panels such as lift gates and doors, etc. So the overall takeaway here is that high-strength steels and their alloys, as well as aluminum, will continue to see the most growth, but in proportion, we expect composites and plastics to almost double over that time. So now I'd like to focus a little bit on components, as many of the OEMs do when they look at lightweighting. So we look at various metals and materials as the individual components are broken out. So things like aluminum, where aluminum is seeing more heavy usage both in aluminum wheels or aluminum battery components and battery box enclosures, of course, body side, and very heavily within engine. Magnesium components, you see things like seat racks and the crossbars for dash panels or dash panel reinforcements. Composites, a good example would be aluminum or composite truck beds. So not shown here on the picture to the right is an individual component, but within the light duty truck segment, this has made quite a bit of inroads. With respect to composite and thermoplastics, you see hoods, trunks, final mile, as I mentioned, the internal components thereof, final mile delivery vehicles, various components there, and oftentimes sidewall with that lighter duty truck delivery segment that may also be used on a day-to-day basis. Furthermore, the electric drive line itself has the ability to have it lightweighted itself. I've got a slide a little bit later on, I'll be talking about that. Lastly, this is another slide, removing or switching the 12-volt battery that's typically seen within a plug-in or hybrid electric vehicles to a lithium ion, lighter weight, or moving away from batteries altogether towards a next generation DC to DC converter. I'd like to move away from the regulations and individual component discussions and overall market trends and talk about what Parker Lord within the Assembly and Protection Solutions divisions, what we have to offer in terms of solutions for that lightweighting. They're going to hit a couple of broad categories of adhesives, some of the thermal materials, so thermal interface, gap fillers, etc., as well as coatings. Now, before I step off into some of the individual solutions, I'd like to talk about and highlight some of the reasons for adhesives being used in conjunction with lightweighting materials. So traditional materials, oftentimes when you're incorporating a lighter weight material, particularly with respect to metals such as magnesium and steel, they won't work together as you're unable to weld these differing metals together. Furthermore, traditional joining methods, when with Class A surfaces in particular, those visible surfaces on light duty trucks and cars, it's not always aesthetically acceptable to use mechanical fasteners. This is also true within the final mile delivery segment. Those new clean sheet designs, often the customers demand a better aesthetic appearance. As well, there's some cost and time. It's often overlooked because it's a traditional method of assembly, but whenever you're putting mechanical fasteners and using those to join various surfaces together, a composite sidewall to an aluminum extrusion, for example, you've essentially put a hole in there. And although it's well known, there's also a sealing option that has to come with it. So these are often multiple steps involving labor, which can be overcome by using adhesives. So again, those offer the adhesives, you offer the ability to bond and seal in one step. You can accommodate differences in thermal expansion between these dissimilar materials that you might be using to lightweight your designs. As well, there's an increasing stiffness and part performance by unitizing a component. A good example of this would be a panel on frame or sidewall of a truck or door. You have a frame member that is covered with some sort of panel, aluminum, composite, etc. And by bonding all the way around, you unitize that structure and tends to increase the overall stiffness and part performance. Lastly, some assembly options, there's unique part designs and geometries could really only be assembled via the use of adhesives. As I mentioned earlier, in some of the individual areas that manufacturers are focusing on, composite and aluminum truck beds really have come a long way within this market segment. So this is basically using a replacement for the traditional stamped steel beds with a composite or aluminum or combination thereof. You're achieving some of that same performance, but with lighter weight components. Some of those key requirements are the ability to bond those new materials and or cross bond them together, fit into this modified assembly process with these new components and still offer excellent bonding performance. Some of the products we have to offer are Versalock adhesives. I should note that the Versalock trade name is one that we often use with adhesives that are sold particularly or exclusively to automotive OEMs and tier ones. The couple of different epoxy solutions, 208 and Lord 380 epoxy, quite readily known and a good solution within the composite side, and then a Max Lock more for the aluminum composite. Some of the benefits there, just those high performance bonding using those light weights And then many of these products, they offer a family of products, so you have the ability to move across different open times depending on the size of the part or the assembly. I mentioned composite lightweighting with respect to closure panels. Pictures to the right are ones where many different manufacturers, where Parker Lord has been involved in bonding various materials together to offer these lightweighting solutions. Quite often, it's looking at composite or sheet molded composite of some sort in combination with aluminum or thermoplastic composites as reinforcing members within it. So basically, you're replacing some sort of closure panel in these applications with some other sort of material to achieve those lightweighting goals. And again, like the last time, the ability to cross bond those new materials and fit into those assembly processes is critical. We offer a number of products in this area, such as the Lord 38 epoxy, 600 and 800 series acrylic adhesives, as well as the 7545 urethane adhesives. Key benefits here are just the ability to bond those different materials and fit into those production solutions, and still offering a trusted solution within that market space. As I've mentioned before, it is final mile delivery vehicles. So these are ones where either there's a clean sheet design where the manufacturers have been asked by their customers to come up with something new and interesting, or something that would accommodate an xEV platform, bringing those battery electric. Furthermore, there's still quite a few options within this industry where they're upfitting traditional vehicles or traditional platforms, but they may be upfitting with different driveline systems, such as an xEV driveline. So key requirements for some of the products that we'd be offering into this are, again, that cross bonding of new materials, but then the ability to bond and assemble of those traditional materials, as well as alternative materials for those alternative drive lines that are being suggested. Some of the products here, Lord Max Lock series acrylics, 400 series, 7545 urethanes, bonding well to composites and so forth, and painted metals, as well one of the interesting products, Cool Therm TC 2002. So this is a structural adhesive that's thermally conductive, quite often used within assembly of battery components, battery enclosures, drive lines, etc., where you're needing to pull heat out but still need to achieve a structural bond. Again, some of those benefits, just the high performance bonding. Again, a family of adhesives. So we offer those different adhesives that can go shorter open times to longer open times, depending on your assembly process and part size of part. All of these are trusted solutions within assembly that have been out for a number of years and have quite a few vehicles and platforms under their belt. And again, this thermally conductive structural adhesive as an alternate for the driveline assembly is unique in the marketplace. Next generation DC to DC converters. So this is where manufacturers have proposed looking at removing that 12-volt battery system within an xEV. So the 12-volt battery system is typically one that'll be supplying power to the lights, the LED light systems, internal lighting systems, the infotainment system, navigation, etc. So these systems use a 12-volt battery, which is fairly heavy. And so one of the ideas behind lightweighting is moving towards a 12-volt lithium ion type battery, and some manufacturers have already moved to that. But one that's being proposed is looking at next generation DC to DC converters to step down that voltage from the high voltage battery system of 48 volts down to some sort of 12-volt regulated voltage to run these low power systems within the platform. So some of those key requirements here, you can imagine generates quite a bit of heat. So there's that high thermal conductivity as well as flame retardancy and protection. So the UL 94 standards are often looked at. We have a number of different products that are for potting and encapsulation. These are silicone type products, SC320 and 324, 324XL and SC1600, just a workhorse product within potting and encapsulation. All these products have that high thermal conductivity, so you're pulling heat back away from the individual electrical components and into the heat sink so it can be pulled out. Many of them are low viscosity and self-leveling, but are able to flow into very small crevices and very small part geometries. As well, there's a range of working times depending on their manufacturing needs. I mentioned lightweighting components like the DC to DC converter to replace that 12 volt. Another example here is within the electric motor or electric driveline category. So encapsulating the rotor and stator really leads to increased thermal and electrical performance by extension. So one of the things that can be done, much like down gauging, is the ability to increase the electrical flow through a motor by having better potting and by pulling more heat out of it. So there's less impedance of the voltage. What that allows you to do is look at the output of the motor that's needed and then step down to a smaller size because, as you can see here, by increasing the ability to pull heat out of it gives you increased power output. So alternatively, you can certainly increase the output with the existing form factor and get higher performance and market it that way. But we are speaking about lightweighting. So much like down gauging, you're able to pull to a smaller motor and still have equivalent performance. What you're looking for here is that easy to dispense, high thermal conductivity, shock resistant materials, and it's thermally conductive but also electrically insulated. Number of products here, the EP2000, 3500, and again that SC1600. So you have the ability to shrink that component down, but still have equivalent power output. This allows for the pottings and caplets to go inside, those very tight windings, and these are stable up to 200 degrees Celsius, which is suitable for the highest motor class. That's Class H motors. Now we're going to move into more on the batteries themselves, so the xEV platforms. First off, cell to pack design. So what we're looking at here is attaching the cells themselves to the battery enclosure and or the cooling pads themselves. You have to have a thermally conductive gap fillers to improve those thermal management. Again, as the power increases and the range goes up, the ability to pull heat out is critical. So some manufacturers, as far as a key requirement goes, look at reworkability and the ability to reuse or repair some of the batteries and or modules. So we've designed products, in this case, SC2000 RW or reworkable product. Certainly high adhesion, easy to dispense, thermally conductive, super critical for these applications, and ULV0 rating. In addition to the reworkable product that I mentioned, there's also the SC3500, UR2000, and again, that TC2002, a structural example. Benefits here are those high manufacturing throughputs when you're having automated battery production. We also have the availability of both silicone, urethane, and in this case, even an acrylic solution in terms of chemistry, depending on what's allowable within the plant. Also need low battery insertion force. So as you're settling the battery onto that cooling plate or within the cell itself and within that pack, don't want to break delicate components. You have to be suitable for room temperature and or heat curing. And I should note that these liquid gap filler solutions are really superior to the traditional non-liquid solutions, and that's kind of known as gap pads colloquially within the industry. And in fact, if you look on our website, there's a nice white paper on that showing the performance of a gap pad versus these liquid dispense thermal solutions. Cell to carrier attachment. So these are primarily focusing on cylindrical cell battery construction, but the ability to put the batteries, the cylindrical cells within the plate carriers and hold them. We developed products, this key product here, Lord 5206, acrylic adhesive, that high structural strength and fast throughput, as you can imagine, for these automated applications. Has to have that excellent adhesive strength, formulated to maintain that joint integrity, and it adheres to a lot of the different substrates that are used within these constructions. So the nickel coated steel, polycarbonate, whatever the trays and the carriers might be. So as you're assembling those cylindrical cell batteries, the current collectors go on top. We have the 5206 and or MaxLock series. These are able to bond the current collectors down, liquid dispense, precise applications because you're going to have a need for precision in assembling these batteries, and they're also very fast curing and strong bonds between that cell carrier itself or the cell holder and the current collector material itself. Overall, what you're really trying to do here is have the assembly withstand vibration that can damage those wire bonds that are soldered in place. And so also you have to have the ability to rapidly apply these materials due to the volumes necessary to produce these batteries. So we've built up the batteries in various forms and we put those battery components down. Now it's up to enclosing and sealing the module. Basically, some manufacturers are looking for either a structural or non-structural solution in combination with mechanical fastening, and we offer both of those. In the end, these products really do provide a seal and protect the batteries from moisture, penetration, and dust, etc. So, kind of those key requirements, most often it's liquid dispense, continuous moisture, and chemical barrier. right, for the batteries and the cells to the external environment, and to some extent, vibration dampening to reduce the noise. Some of the products we offer here, again, the 7545 urethane family, 7610, a one component material, MaxLock, and the 850 series. Again, key to this, liquid dispense, so you can rapidly put this in with metering equipment. The non-structural material needs to flow, be able to be pulled apart and for repairs. And so removing the mechanical fasteners and then also pulling these things out, and also to some degree end of life cycle for recycling. The structural seals can certainly bond the dissimilar materials and eliminate the need for mechanical fasteners altogether. So we've gone through a number of different applications, from structural applications to thermal to battery, etc. Now I'll touch briefly on charging and infrastructure. There certainly is a demand, irrespective of the platform of the xEV, to offer public charging, and the development of faster charging increases the need for assembly and protection solutions. These high-powered charging systems, grid solutions, and integrated charging. So key requirements here, protection for heat, electricity, dust, thermal moisture. The end consumer using these devices, of course, has to be protected as well. So you have to have high thermal conductivity, durability, flame retardancy, the UL94 rated, and then compatible with the substrates that are being used to assemble these solutions and manufacture them. So we offer a number of these products within that charging and infrastructure. You are a urethane product, 288 and 389 for potting and encapsulation, and for assembly, the 5206 product. These offer, the moderate to high thermal conductivity, but low enough viscosity for potting and flowing into the crevices, but sometimes not too far. It's kind of a critical aspect to it. Many of them are self-leveling and offer that good adhesion to the plastics and the various materials. And at the end of the day, you need a fast gel time to prevent leakage during that cure. So I want adhesive to go where I want it and nowhere else. Last on the list, I want to mention a couple of coatings. So we've formulated a number of coatings that are designed really for either thermal conductivity, but at the same time for electrical insulative in nature. The first one here is the JMC 700K. So it's a heat cure product. It's thermally conductive coating, and it's really where you need superior environmental and electrical protection. So again, that electrical insulation. Primarily, you see it within battery enclosures, those battery ribbon cooling elements or cooling plates themselves. All of them designed to eliminate kind of brittle coatings that are typically being used for this electrical protection, and or very thin film layers that tend to get applied. The JMC, although it's a heat cured product, many manufacturers look for something faster, faster production, and faster production is some of the things we hear all the time. So we've responded by offering a VOC dielectric coating, which cures via ultraviolet light in seconds. It does provide that dielectric protection without the risk of delamination that you would normally see with thin films, and superior adhesion to metals and plastics. We have some white papers on this on our website, but basically this product is designed to replace some of the PET used on cylindrical and prismatic cells and improve that bonding and kind of eliminate that delamination. With respect to cooling plates and cooling ribbons, this material, the Sipiol UV, is designed to replace those epoxy powder coatings that are typically used on them and are prone to cracking, etc. And it really does give that increased throughput, and at the same time decreasing the thickness. And lastly is edge protection. Again, I suggest looking up the white paper on this one on our website. If you'd like to have more information, my name again, Steve Webb. Here's my email address. And now I'd like to open up for questions. Thanks again.